Yes, welcome back to the session. In this video, I'm going to discuss about rectifier and half wave rectifier. Okay, so look at the definition first. A rectifier, it is a device which converts alternating current into direct current. So in that, the first one is a half wave rectifier. Look at the circuit diagram here. So this is the primary coil of a step down transformer which is connected to the AC input voltage. So here this is the AC input voltage. Okay, so here I am assuming a primary coil is a P1 and P2. And look at here, we have a secondary coil. Let us assume that is S1 and S2, which is connected to the PN Junction Diode through a load resistance RL. So here, this is the load resistance. This load resistance will give the resultant output. Okay, suppose when key is closed means the primary AC input voltage which gives input voltage signals like this. So the resultant wave will be like a sinusoidal wave. So in this sinusoidal wave, we can assume this is a positive half cycle and this is negative half cycle. Okay, so in this positive half cycle, in this complete cycle, I'm taking only first half cycle, that is a positive half cycle. So for positive half cycle of AC input, there is a current flowing through the primary coil. This current creates an induced EMF in the secondary coil because of mutual induction. So whenever an EMF was generated in the secondary coil here, therefore S1 of the secondary coil will behave as a positive charge and S2 of the secondary coil will behave as a negative charge. Okay, so whenever S1 is a positive charge, this positive which is connected to the P region of the PN junction diode. Okay, similarly S2 is negative, right? So this negative charge which is directly connected to the N region of the PN junction. Okay, so we know that when positive terminal is connected to the P region and negative terminal is connected to the N region, that is nothing but the PN junction is under forward bias condition. Okay, so whenever the PN junction is under forward bias, the size of the depletion region decreases. Therefore, there will be a steady current which is passing through the PN junction. Okay, so whenever a steady current which is passing through the PN junction like this, will get a resultant output in the load resistance RL. Okay, so we gave first a positive half input, right? So only positive half cycle of input we have given. Okay, so for that we got resultant output in this load resistance. So look at the graph here. So this is the input voltage. So first I took a positive half cycle. For this positive half cycle, I got resultant output in the load resistance, this one. Okay, so this is the output of this positive half cycle. Okay, just a second, I will erase everything. Yes. Now, I told you already, here AC input will be like a sinusoidal wave. So for first positive half cycle was completed, the next one is negative half cycle, that means this one. Okay, so for negative half cycle of AC, again there is a current is passing through the primary coil P1 and P2. This current induces an EMF in the secondary coil S1 and S2. So during negative half cycle of AC, this S1 of the secondary coil will behave as a negative pole, so I mean a negative charge. Similarly, S2 of the secondary coil will behave as a positive charge. Okay, so whenever S1 is negative charge, the negative charge is directly connected to the P region of the PN junction diode. Similarly, S2 is positive charge, right? This S2 is directly connected to the N region of the semiconductor. So whenever negative charge is connected to the P region and positive charge is connected to the N region, the resultant PN junction diode which acts as a reverse bias condition. So whenever a PN junction is under reverse bias, I told you already, the width of the depletion region previously will be like this. So due to this reverse bias, slowly the width of the depletion region increases. So whenever the width of the depletion will be large, we can say that inside the PN junction diode, there will be maximum resistance was developed. There is no flow of current in the PN junction diode. Okay, so we gave negative half cycle of input. Look at this graph here. We gave negative half cycle of input. But there is no current was passing through the PN junction diode, and we are not at all getting any output in the load resistance. That is the reason, look at the graph here, for negative half cycle, yes, for negative half cycle, we didn't get any output here. So that means zero output. Okay. Similarly, we know that it's like a sinusoidal wave, means one positive half, one negative half. So for positive half, we got output here. For negative half, we didn't get any output. Again, next one is what? Again, positive half. So that means this one. For next positive half also, we'll get certain amount of output in the load resistance. Again, for negative half means no output. Again, for positive half means again we'll get some amount of output here. Okay, so what I'm going to tell here, as a result, we are getting only for positive half cycles of input. Whatever the output we are getting here, this output always for positive half cycles of inputs. But for negative half cycles of inputs, we are not at all getting any output here. So there is no output here, there is no output here. So that is the reason the half wave rectifier, which means the process is called half wave rectifier. Okay.